All right, 8.3, show that a quadrilateral is a parallelogram. Quadrilateral is a parallelogram. Put my little parallelogram to make it nice and clean. Parallelogram. Learning objective. Students will be able to decide if the quadrilateral is a parallelogram. Yay for parallelograms. All right, in order to do this, we're going to have to do some proving. So let's come over here and do our first proof. Notice we're trying to prove that parallelogram, or this figure ABCD, is in fact a parallelogram. We've got some givens marked up for us. They're already there. And let's go ahead and map out our proof before we begin. Now, in order for it to be a parallelogram, the opposite sides are going to have to be parallel, or some other things we can use from later on. For now, let's prove they're parallel. So I need to say this one's parallel to this. Well, if these two angles are parallel, then these two lines must be parallel. Excuse me, if these two angles are congruent, then these two lines must be parallel. Likewise, we can say the same thing for those two. I'm going to go and erase my markup so that I can use it while working out the proof. All right, first thing you do is start off with your givens. So I'm going to write as neatly as possible on this board, but it's a little sloppy. The reason I can give for this, CD, is obviously it's given. All right, so we got our givens. Now I need to be able to say that this angle is congruent to this one, but before I do that, I need to say these two triangles are congruent. And this is one that you've seen before with proving triangles congruent, so we need to say that that mid-segment in between, or that segment in between, excuse me, is congruent to itself. The reason we can give for this is reflexive property. Reflexive property would be sufficient. Then let's go to statement number 3. Now I need to say that this angle is congruent to this one, because I need that to say that the two lines are in fact parallel. So let's go ahead and make that statement here. Angle BCA is congruent to angle BCA is congruent to DAC. Likewise, I can say that BAC is congruent to DCA. And the reason I can give for this is corresponding parts of congruent triangles are congruent. These two angles are corresponding in the two triangles, therefore they're congruent. And these two angles are in fact congruent as well. Now with that, we can make our next statement about the parallel lines. So now we can say that BC is parallel to AD, and we can say that AB is parallel to CD. Now the reason I can give for these two statements is because of the alternate interior angles converse. Remember that if alternate interior angles of two lines are congruent, then the lines themselves are parallel. So we'll just write converse of alternate interior angles of parallel lines. We'll just write of parallel. Not very neat. All right, we've stated that these are parallel and these are parallel. Now we actually need to make the statement about the parallelogram. So I'm going to write ABCD is a parallelogram. Oops. And the reason I can give for this, well, that's quite plainly the definition of a parallelogram. That's it for our first proof. I'm going to go ahead and skip the second one, but I'm just going to talk it out because I think for the sake of time in the video and for my own personal sanity, I'm not going to actually write this one out. Alright, so if these two angles are congruent and these two angles are congruent, then we can make a statement about the quadrilateral. Let's see, if we call this x and this x, we can call this y and this y, then the sum of the four angles must be 360. Well, that means that x plus y must equal to 180. And if these two angles are equal to 180, then they're supplementary. And if they're supplementary, these are parallel. Likewise, these are parallel. Obviously, not actually writing it out formally in a two-column proof takes a lot less time. Let's go ahead and go to the next one. I'd like for you to pause the video, try this before I show you my solution, and see if you get the same thing. Note that it says WXYZ, so it's got to go around the perimeter. It actually doesn't matter which one's which. I just made sure that the acute went with the acute and obtuse with the obtuse. Well, you can see that 138 plus 42 is equal to 180, and this is 42. That means this one's 138, because the sum of all three angles must be 360. Therefore, this one must be a parallelogram by the theorem that we just talked about just above. All right, let's keep going. We've got that QR is congruent to, or excuse me, parallel to PS, and QR is congruent to PS. I would like for you to try this problem try this proof before I show you my solution strategy. I'm going to pause the video and work this out and see if you get the same. All right, I'm just going to talk it out now that I've got it up here. We have the given. QS is congruent to itself because of the reflexive property. RQS is congruent to PSQ. That angle is congruent to that one because of alternate interior angles of parallel lines, and it's the converse. PQS, the triangle, is congruent to RSQ because of SAS. And I have PQ is congruent to SR, that's this segment and that one, because of corresponding parts of congruent triangles are congruent. Therefore, PQRS is a parallelogram because the opposite sides are congruent and it's quadrilateral. Awesome. Let's go to the next one. All right, diagonals JL and KM bisect each other. We're going to prove that this is, in fact, a parallelogram. Actually, for the sake of sanity and for the sake of time, I'm just going to talk this one out without actually writing out the proof. You might just scribble through this and write out some of the things I'm going to say. Note that these two are bisect each other. That means that these two segments are congruent because that's the definition of bisector. And these two are congruent. Well, this angle is congruent to this one. And if those two angles are congruent, then these two triangles, this one and this one, are congruent. Likewise, I can say that this one is congruent to this one, this triangle. Those angles are congruent, and these two triangles are congruent, therefore these two triangles are congruent. Now, if I've proved that this triangle is congruent to this one and this one is to this one, then I can use that in verifying that this segment is congruent to this one by CP-CTC, and this one is congruent to this one. Therefore, alternate sides, if opposite sides are congruent, then the quadrilateral is in fact a parallelogram. Awesome. Let's go to this one. When we do the algebra, you'll notice it's going to get a lot simpler. Prove this is a quadrilateral using the theorem we just talked about above. All I would need to do is set 5x minus 8 equal to 3x. And then we just go through and solve by adding, subtracting 5x from both sides. And we get negative 2x. That means that x is equal to 4. Doing a quick check. Yep, checks out. Go ahead and pause the video. I want you to try number 2, 3, and 4 before I show you. This one's just asking what theorem can you use. Looking at the theorems on page 522 and 523, you would say this one because one pair of opposite sides are parallel and congruent. This one makes it a parallelogram. So that's that. Opposite sides are congruent, therefore it's a parallelogram. Opposite angles are congruent, therefore it's a parallelogram. Number 5, what value of x is quadrilateral MNPQ a parallelogram? Explain your reasoning. Likewise, we're going to have to set these equal to each other and solve. And I got x equals 2. Let's go ahead and verify that this is in fact a parallelogram. We can approach it from several different standpoints. We could say that this is congruent to this segment. That would require the distance formula 4 times. We could say that this one is congruent to this one, likewise. Or we can say that opposite sides are parallel. Or we could say one pair of opposite sides is parallel and they're congruent. Personally, I like working with the slope formula if at all possible, so I'm going to choose to do the slope formula, prove that these two are parallel and these two are parallel. I'm going to pause the video and show my work, so go ahead and try this one out before I show you my completion. Actually, in this one, it's pretty simple if all we do is just count it, because we've got nice integer values. So I'm going to count it by 2. 1, 2, 3, 4, 5. That meant that this slope has a rise of 2 and a run of 5. This one has a rise of 2. 1, 2, 3, 4, 5, and a run of 5. This one's down 3, right 3, which means it's down 1, right 1. Slope of negative 1 and negative 1. Since opposite sides are parallel, this is in fact a parallelogram. That would be sufficient work if given to you on a graph. If you were given the points, you could either plot it and do this, or do the slope formula. y2 minus y1 over x2 minus